Hey everyone, and welcome to this explainer. Today, we're literally putting on our geologist hats to evaluate the Saurashtra Kutch margin. We're going to look way past the poetry and the epics to uncover the actual physical geography and earth sciences behind the legendary sunken city of Dwarka. Honestly, it is a truly fascinating intersection where myth, history, and just raw geological power all crash together.
Okay, let's dive into this. For our site report today, we're covering the tectonically active margin, where myth meets marine archaeology, the evidence beneath the waves, Holocene's sea level fluctuations, and finally, modern coastal vulnerability.
Section 1. The tectonically active margin.
To really understand Dwarka, we first have to establish the geological context of India's western shoreline, because wow, it is an incredibly dynamic environment. Specifically, we're looking at the Saurashtra Kutch margin. This is a highly active coastal zone that is profoundly influenced by major fault systems, ongoing tectonic reactivation, and vertical crustal movements. These forces are actively shaping the Arabian Sea basin right now. The Gulf of Combat, for example, it was actually formed by a major rift that caused a massive, dramatic downsliding of the entire region. So we're not just looking at a static beach here, it's a violently shifting piece of the Earth's crust.
Just to geographically orient ourselves in the Dwarka-Bet-Dwarka coastal zone, take a look at the shoreline's position. It is completely exposed. Sitting right at the absolute westernmost end of the Saurashtra Peninsula, facing the Arabian Sea, this coastal configuration is relentlessly subjected to extreme tectonic forces and hydrodynamics.
So what's actually driving all this? Well, there are several immense tectonic drivers at play on this western coast. We have that downsliding rift in the Gulf of Combat, major regional fault systems, periodic regional earthquakes, and vertical crustal instability. That last one literally means the land itself is uplifting and subsiding over time. Because of these constant, violent tectonic drivers, the seabed in this area often lacks secure stratification. And that's a big deal, because it makes this a highly volatile, completely unpredictable environment for any coastal settlement to try and survive long-term.
Section 2. Myth meets marine archaeology.
Now, you might be wondering, how did ancient human populations record these massive, catastrophic geophysical events? The comparison is absolutely fascinating. In ancient texts like the Mahabharata and the Vishnu Purana, Dwarka is described as being built on submerged land, reclaimed from the sea, and eventually being released into the ocean. For centuries, this was basically dismissed as purely poetic metaphor. But look at the geological reality. We have natural disaster events, including marine transgression, where the sea level aggressively encroaches on the land, as well as regional subsidence and tsunami activity. If we maintain our scientific neutrality, we can actually view these ancient Sanskrit texts as qualitative ancient datasets. They really showcase some remarkable geographical precision regarding coastal displacement. This traditional depiction is essentially the cultural memory of Lord Krishna's city sinking. But from a geographer's perspective, this artwork and the stories behind it act as an early, vivid human record of natural shoreline transgression and tectonic subsidence.
Section 3. Evidence beneath the waves. Now, what's really interesting about this slide is the empirical data. We've looked at the geology and the texts. Now we need to examine the direct evidence found underwater by marine archaeologists, like the pioneering Dr. S.R. Rao. When we juxtapose modern underwater photography with Dr. Rao's original excavation reports, the findings are striking. These aren't just weird natural rock formations. At water depths ranging from the intertidal zone all the way down to 3 to 6 meters, divers have discovered actual, definitive structural anomalies scattered over a vast area. Let's detail the specific marine archaeological inventory discovered down there. We are talking about massive stone walls up to 6 meters thick, plus submerged fort bastions and advanced harbor infrastructure like stone-cut slipways. They also found distinctive triangular stone anchors with 3 holes. And this is just incredible, because those exact types of anchors were used in ancient Syria and Cyprus around 1500 BCE. That highlights a massive scale of ancient globalization. They even found a 3-headed conch shield that perfectly matches ancient textual descriptions. All of this empirical survey data proves beyond a doubt that this was a heavily utilized, sophisticated ancient port center. Section 4. Holocene's sea level fluctuations. To truly understand the submergence of these structures, we need to shift our focus to the macro-environmental data and analyze how the ocean itself has moved over thousands of years. And this brilliantly illustrates the sea level fluctuations on the west coast of India over millennia. Notice the steep, aggressive climb of Holocene sea level rise. The water didn't just slowly, peacefully creep up. There were periods of rapid, dramatic fluctuation that completely reshaped the coastline of the Indian subcontinent.
Let's connect the chronological dots with this geodynamic timeline. Around 10,000 years ago, post-glacial sea level rise initiated. Then, by 3200 BCE, we see a period of very steep Holocene sea level fluctuation. And by roughly 1500 BCE, we have the approximate occupation of the submerged Dwarka port town. When we overlay these marine transgression regression cycles right onto the timeline of human occupation, the story of a fortified city, ultimately swallowed by the sea, makes perfect scientific sense.
Section 5. Modern Coastal Vulnerability. We absolutely must connect the distant past to our present reality here, because this geological evaluation is not just about ancient history. It matters deeply today. I want to pose this direct question to you. What does Dwarka's fate teach us about our modern coastal cities? I mean, we love to build on the water, but if a massive fortified port city could be entirely claimed by the Arabian Sea in antiquity, what does that mean for our current shorelines? Comparative satellite imagery from just 2015 to 2025 reveals a lot. Notice the massive concentration of built-up areas around modern Dwarka. So, the crucial point is that ongoing coastal erosion and rapid modern urban expansion are currently putting both our modern infrastructure and these invaluable underwater heritage sites at severe immediate risk.
Today, we're facing an intense combination of contemporary coastal risks. We've got climate-driven sea level rise, severe coastal erosion coupled with brutal storm surges, rapid anthropogenic pressures from urban expansion, and of course, the ongoing tectonic vulnerability of our modern infrastructure. Make no mistake, the exact same natural, geodynamic forces that claimed the ancient city of Dwarka are actively reshaping our shorelines at this very moment.
I want to conclude this explainer with a quote directly from the research. The findings carry significant implications for coastal heritage management, climate-related sea level risks, and long-term human-environment interactions along the Indian littoral. Dwarka is just a powerful reminder of the ultimate fragility of human settlements against the relentless, indifferent power of physical geography. It leaves us with a provocative thought. As our climate changes and our seas rise once again, are our modern coastal megacities destined to become the underwater archaeological mysteries of the future? Thanks so much for exploring this with